Lesson 311, Word Problems with Dividing Fractions. Number 1, consider the division problem 1/6 divided by 2. Describe a situation this division could represent. All right, so they're asking us to come up with our own word problem here. And I'll just think of one that's maybe Halloween candy related. Let's say that there's 1/6 of a bag of Sour Patch Kids. And, not naming any names, 2 brothers want to share this. Although we know how brothers share, don't we? It might not exactly be a 50-50 split, depending on who's involved. Again, not naming any names here. Draw a diagram to represent the division and find the solution. All right, so first let's come up with our model of 1/6, because we're dealing with 1/6 of a bag of Sour Patch Kids. And there you have it. There's 1/6, one part shaded out of 1, 2, 3, 4, 5, 6. Now, 2 brothers want to share it. If we do a fair split, how much would each get? Well, what is this amount? It's half of 1/6. Well, let's split this, split this, split this, split this, split this. Count them up. One part shaded out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If you said 1/12, you were correct. 1/6 divided by 2 equals 1/12. Let's prove that, knowing what we know about how to divide fractions. 1/6 divided by 2 can be shown as 1/6 divided by 2 over 1. And then I keep what's on the left the same. 1/6 remains 1/6. Change the symbol from division to multiplication. Flip what's on the right. Multiply across the top. Multiply across the bottom. Checks out. 1/12. All right, moving on. Number 2, a rectangle has an area of 13 square feet and a length of 8 feet. What is its width? Well, first think back to our formula for calculating the area of a rectangle. We know that is length times width. So we've got the area that's given to us as 13 square feet. We've got the length that's given to us as 8 feet. We want to find the width. How does division come into play here? Well, without getting too boring in my explanation, if I know that the area equals length times width, I can simply divide out both sides by the length. I can divide this side by the length and this side by the length. And these lengths will cancel. And width, which is what I'm trying to solve for, is equal to the area divided by the length. We write that formula down. The width is equal to the area divided by the length. Okay. So width is equal to 13 divided by 8. We know we can rewrite both of those whole numbers as themselves over 1. Now at this point, I can keep what's on the left the same, change the symbol, and flip what's on the right. 13/8 is improper. How many times does the 8 go into 13? Once. What's that leftover amount? 5/8. And there you have it. And the unit, of course, is feet. I'm running out of space. 1 5/8 feet. Very good. Let me move the paper up here. Number 3, Rochelle is making 1/4 of a pound of trail mix. She wants to use equal weights of 4 ingredients to make the trail mix. How much does each ingredient weigh? Ho ho. Well, there's some hikers out there who have the theory that since you're already planning to be outdoors and active, instead of trying to load up your trail mix with a bunch of healthy stuff, don't be shy to throw some M&Ms in there. I don't know if that's necessarily good advice, but just saying. 4 ingredients. And when we have this trail mix all together, it should be 1/4 of a pound. So how much does each ingredient weigh, assuming that we're using the same amount, equal weights of each ingredient? Well, sounds like division. 1/4 divided by 4. Show the whole number as itself over 1. Keep what's on the left the same. Change the symbol. Flip what's on the right. And bring it on home. 1 times 1 is 1. 4 times 4 is 16. Each of these 4 ingredients should weigh 1/16 of a pound. Number 4, Mal is 15 years old. This is 1/5 as old as her grandmother. How old is her grandmother? Okay. So, in other words, her grandmother is 5 times her age. So, in a way, we could solve this using multiplication or division. The grandmother's age divided by 5 is equal to 15, or 15 times 5 is the grandmother's age. Let me make a model of this, a visual model just to show you. Let's say that one of these 5 boxes is 15 years old. That's how old Mal is. This number, this age, is 1/5 as old as Grandma. So we could say that Grandma's age here is Mal's age, 15 multiplied by 5. And to me, that's, even though I know we're focused on division, to me, thinking about this in terms of multiplication makes a lot more sense. 15 times 5. And when you go to work that out, you get 75 years old. Number 5, Tariq is making candles for his friends. He has 3 pounds of wax and is using 1/6 pounds of wax for each candle. How many candles can Tariq make? Okay. So he's got 3 pounds, and we're dividing up that 3 pounds into smaller portions that are each 1/6 of a pound, trying to determine how many candles we can get out of this. So 3 pounds divided into portions that are 1/6 of a pound each. Let's rewrite this showing the whole number as itself over 1. Let's keep what's on the left the same and change the symbol and flip what's on the right. And 3 times 6 is 18. 1 times 1 is 1. We got enough for 18 candles. Finally, number 6. Quentin's delivery route is 1/2 of a mile long. He had to break the journey into 4 equal parts. How long will each part of his journey be? Okay, so let's say that this was the distance, 1/2 a mile, and he's breaking it up into 4 equal parts. What's the length of each of these parts? So we're talking about 1/2 or 1/2 a mile divided by 4. Let's show the whole number as itself over 1. Let's keep what's on the left the same. Change the symbol. Flip what's on the right. and we get 1/8 of a mile.